will explore what matter is, the different states of matter, their properties, how particles behave in each state, and how matter changes from one state to another. Matter is anything that has mass and takes up space. Everything around us, air, water, rocks, and even you, is made of matter. Examples of matter include solids like rock, liquids like water, gases like air, and also humans like you and I. These are all forms of matter because they have mass and occupy space. Let's take a look at each state of matter and their properties individually. Matter exists mainly in three physical states: solid, liquid, and gas. Each state has different characteristics based on how particles are arranged and how they behave. We would explore each state individually and understand their properties. Let's look at the properties of solid. Solids are the most rigid state of matter. They have a fixed shape and a fixed volume. This means that a solid object will not change its shape or size unless a force is applied. Solids cannot be compressed because the particles are packed very tightly together with no gaps. The particles in solids are arranged in a regular and orderly pattern. They do not move freely but only vibrate in their fixed positions. The forces of attraction between particles in a solid are very strong, which keeps them held firmly together. This strong bonding is why solids retain their shape and structure. Now let's explore the properties of liquids. Liquids have a definite volume but no fixed shape. This means they take the shape of whatever container they are poured into. Unlike solids, liquids are slightly compressible because there are small spaces between the particles. The particles in a liquid are not arranged in a fixed pattern. They are close together but can move around each other freely, allowing the liquid to flow. The forces of attraction in a liquid are weaker than in a solid but still strong enough to keep the particles in contact. This gives liquids the ability to flow while maintaining a fixed volume. For gases do not have a fixed shape or a fixed volume. They spread out to completely fill any container they are placed in. Because the particles in gases are far apart, gases are highly compressible, they can be squashed into smaller spaces. The particles in a gas are spaced widely apart and have no regular arrangement. They move freely and very quickly in all directions, colliding with each other and the walls of the container. The forces of attraction between gas particles are extremely weak, almost non-existent. This allows gases to expand and fill any available space. This table compares the basic properties of solids, liquids, and gases. Solids have a fixed shape and volume. Liquids have a fixed volume but no fixed shape. Gases have neither a fixed shape nor volume and are highly compressible. Changes in state occur when heat energy is added or removed. Heating or cooling a substance affects the motion of its particles. Let's take a look at melting. Melting is the physical change where a solid turns into a liquid when heat is applied. As heat is added, particles in the solid absorb energy and begin to vibrate faster. Eventually, the energy becomes enough to overcome the strong forces holding the particles in place. The particles break free from their fixed positions and begin to move around each other. This marks the transition into the liquid state. Boiling. Boiling is the process where a liquid turns into gas throughout the entire liquid, not just the surface. As more heat is added, particles in the liquid absorb energy and move faster. When the particles have enough energy to overcome the forces holding them together, they escape into the air as gas. This causes bubbles to form and rise to the surface. Boiling occurs at a specific temperature known as the boiling point. Condensation. Condensation is the process where a gas changes back into a liquid. This happens when gas particles lose heat to their surroundings. As they cool down, the particles move more slowly and lose energy. They start to come closer together as the attractive forces between them become stronger. Eventually, the gas becomes dense enough to form a liquid. Freezing. Freezing is the change of a liquid into a solid when heat is removed. As the liquid cools, particles lose energy and begin to move more slowly. The attractive forces between the particles become stronger as they lose motion. Eventually, the particles settle into a fixed and orderly structure. This process occurs at the freezing point of the substance. Sublimation. Sublimation is a special process where a solid changes directly into a gas without passing through the liquid state. This usually happens when the solid absorbs enough energy for the particles to break free all at once. The particles gain energy quickly and spread out to form a gas. A good example is solid iodine, which turns into a purple gas when heated. Dry ice, which is solid carbon dioxide, also sublimes into gas. Deposition is the reverse of sublimation. It occurs when a gas changes directly into a solid without first becoming a liquid. This happens when gas particles lose a large amount of heat very quickly. They slow down so much that they arrange themselves into a solid structure immediately. A common example is the formation of frost from water vapor on cold surfaces. Challenge time. Can you explain what happened when a block of ice was left in the sun and disappeared, using the particle model?